Good morning, students. I'm Sangeeta, designation lecturer, branch general section, Institute GPT Narankar, semester 1, subject general engineering chemistry, subject code 18C104F, major topic electrochemistry, duration 30 minutes, subtopic problems on Faraday's laws, teaching aids, PPT, animations, diagrams wherever required. So today's our topic is problems on Faraday's laws. Let us recollect what we have discussed in the last class. So what we have discussed in the last class, Faraday's first law and Faraday's second law. So once again we will revise those laws. So what is Faraday's first law? What is the statement of Faraday's first law? So the weight of substance deposited or liberated at electrodes during electrolysis is directly proportional to the quantity of electricity passed through electrolyte. Okay. So whatever the quantity of electricity we are passing, so that much amount will be deposited at the electrodes. That is the statement of the Faraday's first law. According to Faraday's first law, W is directly proportional to Q, where W is weight of substance in grams, where Q is quantity of electricity passed through electrolyte in coulombs. So where Q is given by the formula C into T. So if you remove proportional, that is, if you substitute this Q here, then what happens? W is directly proportional to C into T, where C is nothing but current in amperes and T is equal to time in seconds. If you remove proportionality, you will get proportionality constant. That proportionality constant is represented by small e. Then W is equal to ECT, where E is equal to electrochemical equivalent. So units of weight by Q, grams per coulomb, or W by ampere per second. Okay. So then come to the electrochemical equivalent. So by passing 1 coulomb of electricity, whatever the weight depositing, that is called as electrochemical equivalent. And Faraday's second law. So what is the statement of Faraday's second law? Whenever the same quantity of electricity is passed through different electrolytes connected in series, whatever the weights of substances formed at the electrodes are directly proportional to their equivalent weights. That means here we are taking different electrolytic solutions and we are connecting it in series, and onto those electrolytic solution we are passing same quantity of electricity. When you pass same quantity of electricity, whatever the weights depositing at the electrodes are directly proportional to their equivalent weights. That W is equal to directly proportional to E. See here the diagram, we are taking different electrolytic solutions and we are connecting in series anode and cathode, anode and cathode. And this electrolytic solution we are passing same electric quantity of electricity. So what happens? The substances will be deposited at the respective electrodes are directly proportional to their equivalent weight. So here H2SO4, CuSO4, AgNO3 and ZnSO4. So you imagine this is ZnSO4. So here we are taking any two solutions, that is zinc sulfate and copper sulfate solution. So W1 is weight of zinc, W2 is weight of copper. Similarly, E1 is equivalent weight of zinc, E2 is equivalent weight of copper. So W1 is directly proportional to E1, W2 is directly proportional to E2. So whatever the weights are deposited at the electrodes, they are in the ratio of their equivalent weights. So W1 by W2 is equal to E1 by E2. According to first law, what is W? ECT. So W1 will become E1CT, W2 will become E2CT. So substitute these values in the above equation. E1CT by E2CT is equal to capital E1 by capital E2. CT cancels. So E1 by E2 is equal to E2 by E2. So from this, you get relation, that is capital E is directly proportional to small e, where proportionality remove, you will get a proportionality constant that is represented by capital F, that is nothing but Faraday 1 Faraday is nothing but 96,500 coulombs. That is small e is equal to capital E by F, where capital E is atomic weight by valency. The small e will become atomic weight by N into F. If you substitute this formula in W is equal to UCT, W is equal to atomic weight into C into T by N into F. And W is equal to, this is nothing but E is CT by F. C into T is nothing but Q. So W is equal to EQ by F. So what is E? So when you pass 1 Faraday or 96,500 coulombs of electricity, whatever the weight depositing, that is called as equivalent weight. So this is the relationship between small e and capital E. So E is equal to capital E by F, where F is equal to Faraday. Faraday is nothing but 96,500 coulombs. Okay. So here, today we are discussing problems on Faraday's laws. So what are the objectives? After completion of this period, you would be able to understand problems on Faraday's laws. So if you want to solve the problems, you should know the formula based on first law and second law. So what is the formula based on first law? W is equal to ECT. And then this is the formula for second formula. Three formulas are given here. W, when atomic weight is given, this is the formula. When equivalent weight is given, this is formula. When quantity is given, this is the formula. Okay. So here for different electrolytic solutions, same quantity is passed. This W1 by W2 is equal to E1 by E2. This is the formula. So if you remember this formula, then you can solve the problems easily. Now we will solve some problems that is formed on Faraday's laws. So okay, what is the first? A current of 3 amperes is passed through silver nitrate solution for 20 minutes. Deposited 4 grams of silver. What is the electrochemical equivalent of silver? So read the question carefully. So here what is doing? Current of 3 amperes is passing through silver nitrate solution. For how many minutes? 20 minutes. So how much weight is deposited? 4 grams. So what he is asking? Electrochemical equivalent. So his current is given, time is given, and weight is given. And he asked to calculate small e. So you have to write the given data, current 3 amperes, time 20 minutes. Always you have to convert into seconds. So 1 minute is equal to how many seconds? 60. So 20 into 60 is equal to 1200 seconds. So weight is 4 grams. So you ask to calculate ECT. So E. So W is equal to ECT. So bring E outside. E is equal to W by CT. W is 4, C is 3, and time is 1200. So if you do this calculation, you will get this much. 0.0011 gram per coulomb. So units for E are W by CT, that is Q, gram per coulomb. So this is the answer. Then next come to the second problem. A current of 0.5 amperes is passed through molten AlCl3 for 96.5 seconds. Calculate the mass of aluminium deposited on cathode. See here how much current is passing? 0.5 amperes. Onto which solution? Molten AlCl3. For how many seconds? 96.5 seconds. So what he is asking? How much mass is deposited on the cathode he is asking. That means you have to calculate the weight of aluminium deposited on the cathode. So current is 0.5 amperes. Time is equal to 96.5 seconds. So already is given in seconds. So no need of conversion. Then, so here he has given the molecule AlCl3. So here current and time is given. So and he asking weight. Okay. So then you have to know the atomic weight. So what is the atomic weight of aluminium? 27. So what is Faraday? 96,500. So what is the valency of aluminium? It will split as Al plus 3 Cl minus. So valency of aluminium is 3. So this formula you have to use. Current given, time given. Then he asked you to calculate W and is not given the atomic weight. Very simple element, no? So you should know the atomic weight. So this formula you have to use. Atomic weight into C into T by N into F. So you know the all the factors. So substitute here. So atomic weight. So how much? 27. Current 0.5. Time 96.5. By N is 3 and 96,000. 96,500. Just 1 Faraday also you have to remember. Okay. 27 into 0.5 into 96.5 by 3 into 96,500. So if you calculate this one, you get this answer. So what is the weight of aluminium deposited at the cathode? 4.5 into 10 to the power of minus 23, sorry, minus 3 grams. So like this, you have to calculate the weight. If molecule is given, current, time is given, then he asks you to calculate. You have to calculate by using that formula. Then come to the third question. 0.5 grams of silver was deposited by passing certain amount of current during electrolysis of AgNO3. Find the amount of current in coulombs. So read the question carefully. 0.5 grams of silver was deposited by passing certain amount of current during electrolysis of AgNO3. Find the amount of current in coulombs. So here some weight is deposited by silver, okay, by passing certain amount of current. So during electrolysis of AgNO3. And he asked to calculate the amount of current in coulombs. So W is 0.5 grams and atomic weight of silver is 108 grams and N value for Ag, that is AgNO3 will split as Ag plus NO3 minus, so valency is 1, F is equal to 96,500 coulombs. So here atomic weight is there, okay, N is there, F is there. What is not there? This C into T is not there. This one only you have to calculate. So what he asked, find the amount of current in coulombs. That means C into T is nothing but Q. That means you have to calculate the C into Q, you have to calculate. So C into TQ, bring outside, then what will become? W into N into F by atomic weight. So 0.5 into 1 into 96,500 by 108. So all factors are there. You substitute those all factors. And what is answer you are getting? For 446.759. These many coulombs of electricity is passed on to the AgNO3 solution to deposit this much grams of silver. Okay. So this much quantity of electricity is passed on to the AgNO3 solution to deposit 0.5 grams of silver. That much quantity is passed, then only this much weight is deposited at the cathode. So like this, in any way, if they will give questions, so in what they will ask. So whatever they will ask, you have to find out the problem. So if you read carefully question and write on the given data, then you have to solve the problem. So based on given data only, you get idea which formula we have to use. Okay. Then go to the fourth problem. So a certain quantity of electricity is passed through aqueous solution, okay, of AgNO3 and CuSO4 connected in series. The amount of silver deposited at cathode is 10.8 grams. What is the amount of copper deposited? The atomic weight of silver is 108 and copper is 63.5 grams. So here read the question carefully. Okay. So here two solutions are there and these two solutions are connected in series. A certain quantity of electricity is passed through aqueous solution of AgNO3 and CuSO4 connected in series. So here Connected in series means this problem is based on second law. So here we took two different electrolytic solution. Onto this electrolytic solution, some quantity of electricity is passed. So when some quantity of electricity passed, how much silver is deposited at cathode? 10.8 grams of silver is deposited. And he asking to calculate the what is the amount of copper deposited. Okay. So he has given atomic weight of silver is 108 and copper is 63.5. So write down given data. Weight of silver is 10.8 grams. Weight of copper you have to find out. W2 you don't know. Then you have to find out the equivalent weights. If you know the valency, AgNO3 valency is 1. Ag plus NO3 its valency 1. Copper sulfate it is split as Cu plus 2 SO4 minus 2. So what is the charge present on copper? 2. So its valency is 2. So atomic weight he has given. So you have to calculate the equivalent weights. So equivalent weight of silver is equal to atomic weight by valency, that is 108 by 1, that is 108 grams. Whereas equivalent weight of copper is given by molecular weight by, sorry, atomic weight by valency, that is 63.5 by 2, that is 31.75 grams. So this is based on second law. So according to second law, what is the formula? W1 by W2 is equal to E1 by E2. So you know W1, you know E1, E2, you don't know W2. You substitute these values in this formula, you will get the weight of copper deposited. Okay. So 10.8 by W2 is equal to 108 by 31.75. Cross multiply and bring outside this W2. So 10.8 into 31.75 by 108. Then you will get this much grams. So 3.175 grams of copper is deposited at cathode. It means when you pass same quantity of electricity on silver and copper sulfate solution, so silver is this much deposited and copper is this much deposited. Okay, so this is the next. We'll see the next problem. So fifth question, calculate the number of Faraday's electricity required to deposit 60 grams of magnesium. So 60 grams of magnesium to deposit this much grams of magnesium, how many Faraday's of electricity is required? He is asking. So here, so 1 Faraday of electricity deposits 1 gram equivalent weight of element. So always if you pass 1 Faraday of electricity, how much weight it will deposit? It will deposit its equivalent weight. Okay, so here he is asking 60 grams of magnesium is depositing. So how many Faradays are required? So what is the equivalent weight of magnesium? So what is the atomic weight of magnesium? 24. So its valency, magnesium valency is 2. So do you remember how to do valency? Magnesium loses 2 electrons. Okay, so its valency is 2. So 12 is the equivalent weight of magnesium atom. Okay, so atomic equivalent weight of atom is calculated by atomic weight by valency. So its equivalent weight is 12. So when you pass 1 Faraday of electricity, how much grams deposit? This much grams of magnesium deposits. Okay, so to deposit 60 grams of magnesium, how much Faraday of electricity is required, is asking. Okay, understood? So 1 Faraday of electricity deposits 1 gram equivalent weight of element. So here what is the element here? Magnesium. So you have to calculate the equivalent weight of magnesium. So the equivalent weight of magnesium is given by formula atomic weight by valency. So what is the atomic weight of magnesium? 24. Its valency is 12. So 2, sorry. So valency is 2. 24 by 2 is 12. This is the equivalent weight of magnesium. So when 1 Faraday of electricity passes, this much magnesium is deposited because this is the equivalent weight of magnesium. So whatever its equivalent weight, that weight will deposit by passing 1 Faraday of electricity. So he is asking if 60 grams of magnesium depositing means how much Faradays of electricity is required. So here 12 grams of magnesium is deposited by 1 Faraday. So 60 grams of magnesium is deposited by how many Faradays? So that is 60 by 12 into 1. So that is 5 Faradays. Okay, 1 Faraday deposits 12 grams means 5 Faradays will deposit 60 grams. So 5 Faradays of electricity is required to deposit 60 grams of magnesium. Okay. So these are the some of the problems we solved here. So next, summary. So in this period, what we have discussed? Problems on Faraday's laws. Okay, then we will go for objective type questions. So here, this type of objective type questions you may expect from this topic. So simple problems only they will ask. So we discuss problems now based on problems on the objective type questions. The mass of copper deposited when the same quantity of electricity is passed, which deposits 1.08 grams from AgNO3 solution, same as above. Okay. So here two solutions, silver solution, silver nitrate and copper sulfate, same quantity of electricity passed. See here, when same quantity of electricity are when connected in series means that is based on second law, that is W1 by W2. So just now we did here, no? Just now. Here weight they have given 10.8, there weight they are given 1.08. So same quantity of electricity is passed, this much grams of silver deposited and how much copper is deposited he is asking. Same atomic weight. So atomic weight, equivalent weight remains same, that is equivalent weight is 108 and equivalent weight of copper is same. What are here? 63.5 by 2, that is 31.75. So here in the place of 10.8 you will write 1.08, remaining all same. Then W2 what answer you are getting? That is answer is D, 63.5 grams of copper is depositing. W1 by W2 is equal to U1 by U2. So W1 1.08 by W2 question mark, E1 108 by E2 31.75. Cross multiply. 1.08 into 31.75 by 108, you will get 63.5 grams. So answer is B. Okay. Then next go to second, all problems only. A current of 1.5 amperes is passed through a silver nitrate solution for 35 minutes. The amount of silver deposited is 3.528 grams. So what is the electrochemical equivalent of silver? So here current is given, time is given and weight is given. He asked you to calculate E. So you have to convert 35 minutes into seconds, that is 35 into 60. So bring outside E, W is equal to ECT, E is equal to W by CT. That is W is 3.528 by 1.5 into 35 into 60. If you do this one, you will get answer C, that is 0.00112 gram per coulomb. Okay, we will use this whiteboard. So here 1.5, 35 minutes, 3.52. Okay. So here current is 1.5, time is 35 minutes, that will be converted into seconds, 35 into 60, and weight how much? Weight is equal to 3 point something. Okay, W is equal to E C T. where he asked to calculate E. You don't know E. Okay. So bring E outside. E is equal to W by C into T. So what is E? You see here. I forgot this E. What is E? 3.528. Okay. 3.528. 3.528. 3.528. Then E is equal to 3.528 by 8 by 1.5 into 1.5 into 35 into 60. Okay, 35 into 60. So what answer you will get here? That is 0.111. So whatever your answer is given, this C is the answer. 0.00112 gram per coulomb. So like this you have to calculate. Next, the ratio of volume of H2 and O2 liberated by passing 1 Faraday of electricity through acidified water. So here 1 Faraday of electricity is passing on to the acidified water. So what is the ratio of volume of H2 and O2 liberated? So he is asking. So here options are given: 1:1, 2:1, 1:2, 4:2. So when 1 Faraday of electricity is passed, how much will be deposited? Its equivalent weights. Okay, ratio of volumes. So answer is 2:1. Answer is B. Okay. The next come to the fourth question. How many Faradays of current required to decompose 45 grams of water? So 45 grams of water decompose, how many Faradays of electricity is required? Answer is C, 5 Faradays. Okay, so 5 Faradays. Okay, so one molecule is 18 grams, so 5 Faradays of electricity is required to decompose 45 grams of water molecules. So answer is C. Then next come to the questions. So these are the some of the objective type questions you may expect from this topic. So you have problems now, maximum problems objective questions only you'll get. And come to the questions. So questions, any type of problem they can ask. It is based on first law, second law, whatever it may be. So here I have given two questions. What is the first question? Calculate the weight of copper deposited when 2 amperes of current is passed through CuSO4 solution for 2 hours. So atomic weight of copper is 63.5. So here what he is asking, how much weight is deposited when 2 amperes current is passed through CuSO4 solution for 2 hours. So here time given in 2 hours. So you have to convert into seconds. So 1 hour is how many minutes? 60 minutes. 1 minute is equal to how many seconds? 60. So like that you have to convert into seconds. Then only you have to go to the problem. So weight given, current given, and time given. So atomic weight is also given. So what is the formula used? W is equal to atomic weight into C into T by N into F. So atomic weight 63.5. What is the N? Valency for copper is 2 and C is 2 and current is 2 hours. You have to convert into seconds. And what is F? 96,500 coulombs. So if you calculate, you get some weight. So like that you have to calculate. And what is the second? 0.5 amperes of current is passing through the metal salt solution for 100 seconds. If 0.05 grams of metal deposit, what is the electrochemical equivalent? Okay. So here how much current is passing? 0.4 amperes current is passing through a metallic salt solution. For how many seconds? 100 seconds. So what is the weight depositing? This much weight depositing. 0.05 grams of metal is depositing. So what is its electrochemical equivalent? So this is W is equal to ECT. W there, C there, T there, and he asked to calculate E. So E is equal to W by CT. So W is 0.05 by C is 0.5, T is 100 seconds. Already it is given in second. So you'll get some answer. So like this you have to calculate the electrochemical equivalent. So while solving the problems, you have to carefully read the question. Then you have to understand the question. So after understanding the question, you have to write the given data. Then you have to see what he has given in this question. So what data is there and what he is asking to find out. So to find out this one, which formula you have to use, you should know that one. Then only you can solve the problem. So if you see here, current is there, time is there, weight is there, and he asked you to calculate E. Then what you have to do, what is the formula? W is equal to ECT. So E is calculating, E bring outside W by CT. You see here, current is given, time is given, and he has given atomic weight. And current, time and atomic weight gives. If at all atomic weight also not gives, current, time he gives and he asks you to calculate. So what you have to do? So that formula should click in your mind. That is W is equal to atomic weight into C into T by N into F. If at all atomic weight also not given also, you have to do. Okay. So if atomic weight given, direct that formula. So atomic weight given means valency. You have to find out how you have to find. You have to remember, either you have to remember the valency, or if you know the splitting of the molecule, whatever the charge you will get on this one, that will be the valency. So copper valency is 2, zinc valency is 2, silver valency is 1, like that you have to remember. So atomic weight into current into time. Time in hours you have to convert into seconds. Time in minutes you have to convert into seconds. If it is in seconds, directly you have to write that value. So atomic weight into current into time by N into F. F value also you have to remember. So always. So 1 Faraday is equal to how many coulombs? 1 Faraday is equal to 96,500 coulombs. So like this you have to remember. Then you have to, then if same quantity of electricity, if they said, so here one problem is there, no, the same quantity of electricity is passed through the electrolytes. So what is the weight deposited? So what you have to do, it is based on second law, W1 by W2 is equal to E1 by E2. So there if you won't give equivalent weight means you have to calculate the equivalent weights. So silver atomic weight is 108, copper atomic weight is 63.5, and copper valency is 2, silver valency is 1. So 63.5 by 2, that is 31.75, and silver nitrate, that is 108, its valency is 1. So silver nitrate, not silver only. So 108 by 1. So W1 by W2 is equal to W E1 by E2. So if you know W1, you can calculate the weight of copper by taking W1 by W2. So like this you have to solve the problems. So with this we finish this electrochemistry topic. Okay, so what we have discussed in electrochemistry, starting introduction. Okay, so with the problems we finished electrochemistry topic. So first here we studied the introduction, what are the types of substances, what are the types of conductors, what are the types of the electrolytes. Then we have differences between metallic and non-metallic conductors. Next, we discussed Arrhenius theory of electrolytic dissociation or ionic theory. Then next, we discussed electrolytic cell construction and working of electrolytic cell. Then we discussed electrolysis of fused or molten NaCl. Then we discussed electrolysis of aqueous NaCl. Then we discussed applications of electrolysis. Under applications of electrolysis, we discussed electroplating. Under electroplating, we discussed copper plating. Then next, second application is electrolytic refining. Okay, purification of under purification of metals, we studied electrolytic refining. So in that, which metal we refined, that is copper metal we refined. Then next we studied the Faraday's laws, that is Faraday's first law and Faraday's second law. And this Faraday's first law and Faraday's second law are very important. Here we, in the last period, so I didn't discuss these questions and this objective type questions. So here we will see the once again objective type questions. The units of electrochemical equivalent are gram per coulomb. Then the electrochemical equivalent of metal is x gram per coulombs. Then what is its equivalent weight means? Answer is B. So x into 96,500. So here electrochemical equivalent weight is given. So is asking equivalent weight. So what you have to do? So you have to multiply this 96,500 into its metal electrochemical equivalent. Then you will get the equivalent weight. Then next, the amount of substance deposited at an electrode is directly proportional to. So the amount of substance deposited at an electrode is directly proportional to what he is asking. So answer, quantity of current passed through electrolytic solution. B, atomic weight of substance. C, both. D, none. So what is the answer? This is first law. Weight of substance deposited at an electrode is directly proportional to the quantity of current passed through the electrolytic solution. So this in last class is power problem. So I didn't discuss this objective type questions. That's why I am discussing here. So these are the some of the objective type questions. So first one, charge of 1 mole of electrons. We discussed now 96,500 coulombs. Then units of electrochemical equivalent gram per coulomb. Then next, the electrochemical equivalent of metal is given. What is its equivalent weight means? You have to calculate that equal electrochemical equivalent into 96,500. If you do, you will get the equivalent weight. That is answer is B. Then amount of substance deposited at an electrode is directly proportional to the quantity of current passed through the electrolytic solution. Then what type of questions you may expect from this topic means Faraday's first law, Faraday's second law, and write the units of E and write relationship between E and capital E and small e. So these are for 1 mark question and these two are for essay questions. That is 5 marks question or 3 marks questions. Okay, very important. Maximum times repeated this question for Faraday's first law and second law. So write the statement of Faraday's first law, that is 1 mark question, and write the statement of Faraday's second law, 1 mark question. If at all they will ask for explain Faraday's first law or Faraday's second law, that is for essay question. Okay. So in last class we discussed here, and today's class what we discussed? We discussed problems on Faraday's laws. We discussed all types of problems. If you have still any doubts, we will clarify your doubts in the next class. With this we finished electrochemistry topic. Okay, so whatever you have any doubts, we will clarify. Thank you, students.